The Pythagorean theorem is a way to find unknown sides on a right triangle, and it's important to remember that the Pythagorean theorem is only possible in a right triangle. You may remember from junior high that the Pythagorean theorem is a squared plus b squared equals c squared, or it can be rewritten as c squared minus b squared equals a squared. Now there's only three variables in this theorem. It's a, b, and c. It's important that we label one of the sides correctly, and the other two sides aren't that important on where they go in the triangle. This side that's across from the right angle, this is my hypotenuse of a right triangle. And this hypotenuse has to be labeled C. That is the one thing that we have to have labeled correctly. Now the other two sides, known as the legs of the right triangle, they can be written on either of the other two sides. As long as we have the hypotenuse in the right spot, we are going to be having success with this Pythagorean theorem. We're going to look at two examples of the Pythagorean theorem now, and we're going to use the theorem itself to find the missing sides. So the first example that we'll look at is finding an unknown side in this right triangle. And we're going to give some dimensions here. Let's say this is 10 centimeters, and let's say this one is 13 centimeters. And the side we're trying to look for is right here. One of the first things you should do when you come across these questions is to actually go in and label the sides of the triangle correctly. So since this side here is across from the right angle, this is my hypotenuse, so this is C. Now the A and B do not matter which side takes on those values. So if I'm looking for C, the equation I'm going to probably be using is A squared plus B squared equals C squared, because this is the side we're trying to find. Now we just insert the things that we need to put in. So A was 13, so that's 13 squared, plus 10 squared equals C squared. Now you can go and individually find what 13 squared is, or what 10 squared is, or you can find it all together. And on the calculator here on the left, I'm going to put it in. So I'm going to say 13 squared plus 10 squared equals. So that equals 269. So this whole part here is 269 equals C squared. The last step in the Pythagorean theorem is to get rid of the squared on the C. And one of the operations you should remember is that to get rid of a squared, we simply square root each side. So the square root of 269 is the same thing as the square root of C squared. Square root of C squared is C. And the square root of 269, if we did this, this would be the exact value. This would hold all the decimal places. So the square root of 269 is the length of that hypotenuse. Or we could go in our calculator and say the square root of 269 equals, and if we rounded to one decimal place, that would be 16.4 centimeters equals C. So our hypotenuse here is 16.4 centimeters. One thing when you're doing these questions, if you remember characteristics of a right triangle, you should remember that the hypotenuse has to be the longest side in the triangle. So we should always verify and just check to see that this value of 16.4 is in fact longer than 10 and longer than 13. That at least tells me that my answer is reasonable. Now we're going to look at one last example here on the Pythagorean theorem, and we are going to take it a little bit different. I'm going to say, okay, here's a right triangle, and we'll say that this side is 3 decimeters. And we'll say the hypotenuse is 28 decimeters. And this is the side we're looking for. So now if I examine this triangle, we should be able to see that this side, since it's across from the right angle, this is my hypotenuse. And I have one of the other sides, B, and I'm going to be looking for A. So if the information's written that way, we want to use the Pythagorean theorem in this form. Because this form says, hey, I have my hypotenuse, I have one of the other sides, now I need to find one of the other legs. So the same process comes in, except now we have a subtraction in the middle. So we insert the knowledge we know, 28 squared minus the 3 squared should give me the a squared. Again, in our calculator, we can go and calculate this information. 28 squared minus 3 squared equals 775. So that is 775 equals a squared. And just like in the last example, the last step is to square root both sides to get rid of the squared on, in this case, the a. So the square root of 775 would be the exact value of the length of a, but 775 can be simplified. 775 is the same thing as the square root of 25 times the square root of 31, and that equals a. So as an exact value, square root of 25 is 5. 5 times the root of 31 equals a. This would be considered an exact value. And if we were looking for a decimal approximation in your calculator, we can simply say the square root of 775 to one decimal place is 27.8. So 27.8, and we were using decimeters, is a. This would be considered an approximation. So what we've done here is we've identified that the Pythagorean theorem has to be used on right triangles. It can't be used on an oblique triangle. And there's two forms of it, a squared plus b squared equals c squared minus b squared equals a squared. And we looked at two examples, one finding the hypotenuse and one finding the other side, another side of the triangle. And the answers can be expressed two ways. They can be expressed as an exact value and as a decimal approximation.